So in this problem, we're asked to complete the square to make a perfect square trinomial, and then write the result as a binomial squared, which is typically the purpose of completing the square. Remember, what we're doing here is we're looking for the form ax squared plus bx plus c, and when we complete the square, we divide b by 2 and square it, and that's what we add. I said x, but I wrote c. So ax squared plus bx plus c, we divide b by 2, square it, and that's what we add as c. So in this case, with a squared minus 20a, our b is negative 20. So we have negative 20 divided by 2 squared equals, that's 400 divided by 4, which is 100. So we would then add 100 to both sides. So this then becomes, or add 100 to the expression. So we have a squared minus 20a plus 100, and then that's going to be that's the complete the square part, a squared minus 20a plus 100, and then that can be rewritten as the binomial, whatever this original 20 divided by 2 would be negative 10. Negative 20 divided by 2 is negative 10, so this is a minus 10 squared. Same thing with part B. Our B is negative 5, so we have negative 5 divided by 2 squared. That equals 25. I said 25, I wrote 24. 25 fourths. So written as a perfect square trinomial, that would be m squared minus 5m plus 25 fourths. And then that would be m minus 5 halves squared. What we originally had, b divided by 2, that would be what we're subtracting or adding. In this case, it's negative 5 halves, so it's m minus 5 halves squared, written as a binomial squared. Last but not least, we have p squared plus 1/4 p. So our b is 1/4. So we have 1/4 divided by 2 squared. That equals, let's go ahead and rewrite the what's inside the parentheses first. So 1/4 divided by 2 is 1/8. That's squared, which equals 1/64. So as a perfect square trinomial, that is written p squared plus 1/4 p plus 1/64. And then as a binomial squared, remember it's whatever is inside the parentheses, the b divided by 2, that simplifies to 1/8. So this ends up being p plus 1/8 squared.